All right, hopefully this is working. So let's take a look at round one. Is there one in particular that you feel like you don't like? Well, let's talk about this. It says use long or synthetic division. Remember how you can use long division on any of them, but you can only do synthetic on certain ones. Can you do synthetic on number one? Yes. Number two? Yes. How about three? Yes. Four? No. So here's how you know. You have to be dividing by x plus or minus some number. So I want my lead coefficient to be 1 in my divisor there. Okay. So if I'm dividing by anything else, so number 2 is no problem, but number 4, I'm not dividing by, or yeah, it's not just x plus or minus some number. So this one I have to do long division. So why don't I do, I'll do one of each real quick, one long, one synthetic. So for the long division, or no, let's start with synthetic on number 2. So all I'm going to do is I'm going to drop down my coefficients, 1, 12, 47, 60. I'm going to make sure that I don't need a zero placeholder. 3, 2, 1, none. All my degrees are represented, so that looks good. What's the number that you actually plug in? Am I plugging in 2 or negative 2? Positive 2. I'm always looking at what the 0 would be if that was the factor. So I'm going to pop in a 2. And then I just do, remember you drop down the first number, multiply, I get a 2, and I'm just adding. I get 14, multiply, 28. Oh, these numbers are getting big. 47 and 28 is that 75? Oops. 47 and 28 is indeed 75. 2 times 75 is 150. So 60 and 150, 210. Okay, did you get the same numbers I got? But now the question is, what's my answer? Remember how this works. 210 is the remainder. This is my constant. This is x to the first, and this is x squared. And I would just keep going up like that. Hold that thought. That's a new one, Sabia. Hi. Hello, how are you? Good. We are reviewing for a test, but yeah. Okay. All right. Okay, no problem. Bye. Okay, so yep, so these are my coefficients of what's left. Remainder, constant, x to the first, x squared. If I had more, I would just keep going up. So I'm going to write the answer all nice and neat. X squared plus 14x plus 75. And then the remainder, remember, you just put the remainder 210 over whatever we were dividing by, which was x minus 2. So this whole thing is my answer. So that's what it should look like when you are asked to divide polynomials. You'll get something like that. So on number 4 that I'm going to do with long division, I need to make sure that I'm putting in zero placeholders where I need them. So in my divisor, I don't have an x to the first term. So I'm going to stick that in. And in my dividend, let's see, 4, I don't have an x to the third term. But I do have an x squared term, x to the first, and a constant. So hopefully we can fit this all in, but I think we can. And then remember the procedure. I just asked myself, what do I multiply x squared by to get 2x to the fourth? What would that answer be? What do you multiply x squared by to get 2x to the fourth? 2x squared. So up top in the x squared column, I put 2x squared. I'm going to take that number and multiply it by everything that's out in front. 2x to the fourth plus 0x to the third minus 4x squared. Don't get nervous with the zeros. 0 is a number just like anything else. I need to subtract this whole line. So you're minus, you're now minus. It's already a minus, so it turns into a plus. The first term should always cancel out. Now here I have 0x to the third minus 0x to the third. It's still 0x to the third. Just keep going, even if it's a 0, who cares? And I also have a plus 7x squared. I'm going to drop down my minus x. And then I repeat the process. What do I multiply x squared by to get 0x to the third? Wouldn't it just be a 0x? So up top, 0x, multiply it through. I know it feels silly because it's a 0, but you just go through the motions. 0x to the third plus 0x squared minus 0x. I mean, it doesn't matter if it's plus or minus, right? Because these are, and now subtract the whole line. I know, it feels silly, but first two cancel just like they should. Now my next one, I've got 7x squared minus x. And I'm almost done. I got to drop down that plus 6. And I got to go through one more cycle. What do I multiply x squared by to get 7x squared? Positive 7. So I put a positive 7 up top, multiply it through. Subtract the whole line. So minus, minus, and now this becomes a plus. My first terms cancel just like they should. Then I'm left with negative x plus 20. I have nothing left to bring down, so that whole thing is my, what do you call it, remainder. This one's kind of weird because this remainder is a binomial. So normally I would just write minus and then the remainder on top. But since it's a binomial, I'm going to write it like here. I'm going to stick it in right here. So I'd have 2x squared. I don't need the 0, so I just have a plus 7. And then I'm going to do plus negative x plus 20 over x squared minus 2. And that's my answer for this one. So do you understand why, like normally I put the minus right there and then the number, but because it's a binomial, I would have had to factor a negative out of the 20 also. So you could do that, but then in the numerator, it would have been an x minus 20 and not a x plus 20. If that makes sense. So there's synthetic, there's long division. When you get down to the graphs, remember how we worried about the end behavior. So if we look at something like, let's just look at number 2 on round 2. Oh, it shouldn't be a 2, it should be a 1, whatever. Can someone please tell me what the degree of this polynomial would be? Oh, and you know what? There's a typo on this one too. I'm so sorry. Can everybody look right here? Because I want you to change it to make sure that's right. That cube right there shouldn't be there. It should be on the outside. It should be like that. I'm so sorry. I just remembered that from last year. So yeah, move that cube to the outside. So now, can you tell me the degree? 4, right? I have 1x right there, and then I'm going to have 3 more right here because that's to the third. So if I were to multiply this all together, it would be an x to the 4th. What would the sign of my lead coefficient be? Would it be a positive or a negative? If you multiply all those x's together, it would be negative, wouldn't it? These would just be positive x to the 3rd, but then I'm going to multiply it by a negative x. So I'm going to end up with negative x to the 4th. I don't really care about all the rest of it. That stuff's irrelevant, but this tells me what my end behavior is going to look like. Show me with your hands what this end behavior is. Hooray! Yes, they're both going down together. So like that. Okay. Now, because this one was already factored for me, my life's pretty easy. What is the 0 that comes out of this one? 2 minus x. What would the 0 actually be? 2. And then from this one, x plus 3, and then we put the cube on the outside, I get negative 3, right? But what do I do with like the to the 3rd part? What does that mean? That means you get the answer of negative 3 3 times. So it's a triple root. Or you could get fancy and say you have negative 3 with a multiplicity of 3. That's another way to say the same thing. So that's just saying, hey, I got this same answer, but I got it 3 times in a row. Because remember, I should have 4 total answers. And there they are. I have 1 right here and then 3 of them right there. So now, hello. I think there should be we're going over some review. Thank you. Should be one on your desk. So now I just have to ask myself, at 2 and at -3, what happens? So will the graph bounce anywhere in this one? Will I bounce at 2 or will I bounce at -3? I don't bounce at either one. The only time you bounce is when you get the same answer 2 times or 4 times or some multiple of 2. I got -3 3 times. If it's odd, it passes right through. Only if it's even do we bounce. So at both of these locations, I'm just going to pass right through. I know what the ends look like already. All right, so then again, I'm really only grading this much. I'm grading, do you have the dots at the right spot? Do you have your end behavior correct? And I'm just going to check if you pass through or bounce as you're supposed to. So these should both pass through. It's going to look something like this. I don't know. There might be more detail. I don't really care about that extra detail. So you want to put it in, you figure it out, fine. But I'm not looking at it. I'm looking at, is that 0 correct? Is that 0 correct? Are the ends correct? And did you bounce when you were supposed to bounce? And did you pass through when you were supposed to pass through? So when you get to something like number 4, how are you supposed to do that? Because that's not factored for you. Oh, yeah, you just factor it. So couldn't you take out like a 9x and be left with x squared minus 9? And then doesn't x squared minus 9 just factor into x plus 3x minus 3? Oh, so if you have one that's not factored, you just factor it and then you go from there. Okay, all right. We're cruising right through. Let's see, round 3. What's round 3 all about? Oh, yes. Okay, you're given a root. You got to find the other ones. So I assume we need to practice one of the worst ones. So how about 3? Let's do number 3 together. They gave you 1 root. You got to find how many total are there going to be on number 3? 4. There should be 4 in total. They gave me 1 of them, but they really gave me 2. Because isn't the other one just a conjugate? Yeah. So if they tell me 1 plus I is a root, I know 1 minus I is a root. So cool. I have 2 of my 4 so far. So I'm just going to keep a list up here. So far I have 1 plus and minus I. Oh, and I'm just looking for 2 more. Okay. Where the heck am I going to find them? Well, I'm going to use the fact that I know that these 2 go in to my advantage. I'm going to do that shortcut with the sum and product. If I find their sum, so the sum of these 2 roots would just be 2. The product of these 2 roots, I don't know what it is, but I'm going to find out. So if I FOIL those 2 things together, I'm going to get 1. Outside, inside cancel. Last is a minus I squared. Guys, what's negative I squared really? Negative I squared is really plus 1. I squared is -1. So negative 1, I have 1 plus 1. So my product is 2. So that means that the polynomial that produced these 2 zeros is just this. It's x squared minus the sum plus the product. Oh. So if you were to take this polynomial or this quadratic and divide it into the one that's up there, you should get a remainder of 0. And that's exactly what I want to do. As unfun as that is, at least I know that I should be getting a remainder of 0. So math, thanks math for always having my back. And if I mess up, it's going to let me know. It's going to say, hey, girly, you just messed up right there. You dropped that negative, you silly goose. Go back and fix it. And I was like, oh, math, you're so nice to me. You're always looking out. All right, there we go. I make sure that I don't need any 0 placeholders. 4, 3, 2, 1, none. I don't. Okay, so now you just divide. So x squared up at the top. I'm going to try and do this kind of fast. So hopefully you know what you're doing with the long division. Make sure that, again, little self-checks as you're going even, because those first terms should be canceling out. If they're not, you know you're doing something wrong. Math always has your best interests at heart. And what do you know? I have nothing left to bring down, and my remainder is, in fact, a 0. Yes. Am I done? Oh, you wish. I'm close, though. Now I'm down to this. This is a quadratic I can solve. So if I just solve that quadratic, I'll know what my other two roots are. And luckily, that factors. Thank goodness. If it didn't, I'd have to do quad formula or completing the square. But there are factors of 2 that add up to be 3. Aren't they just x plus 2, x plus 1? So that means my other two factors are -2 and -1. Oops. There they are. Now I have all 4. And I know what you might be thinking. Mrs. Savia, why didn't you just do like those possible rational roots and plug them in? The problem is I don't know if any of them are going to be rational. Right? They could have ended up, it could have been another pair of imaginary numbers. It could have been, I have no idea. I don't know what it looks like. So I didn't know if they were going to be rational or not. So I'm not going to waste my time plugging in every single possible rational root only to find out that there isn't one. In this case, yeah, there were, and I would have found them. All right, cool. But what happens when none of the roots are rational? You would have a very bad time. So I need to sort of go down this road, because if they were going to end up being irrational, that would have been, or imaginary, that would be how I find them. Okay, moving right along. Okay, round 4. Sorry that the numbers are messed up. This should not be a 3, it should be a 1, but I'm sure you can figure that out. All right. Anybody have a preference on round 4? Go so fast. Round 4, anybody? You're looking at 1 and you're like, I would have no idea, Tristan?
3.
I figured 3. So 3, this is that quadratic pattern. Do you guys remember? Remember we did it in the last unit and we're like, hey, you know what? This would be so much easier if I just said y equals x plus 6 for a minute and then rewrote it so it just looks so much nicer. Because now I could just write this as 2y squared minus 5y plus 2. Way easier, and I can factor this thing. So let me factor this. I do slide and divide, you do you. Just don't mess it up, right? So y minus 4 and a y minus 1, but I did the slide, now I gotta do the divide. So I really sneak in 2s. So when I factor this, I'm gonna go over here because I'm in a room. I've got y minus 2 and 2y minus 1. However, I didn't really have y's in the original, so now I got to sneak back in and replace the y's with x plus 6's. So I really have x plus 6 minus 2 and 2 times x plus 6 minus 1. So if I factor these things, or simplify, I should say. So that's going to be x plus 4, and this will be 2x plus 12, but then I got that minus 1. So 2x plus 11, which means my zeros would be -4 and negative 11/2. Yes. If you can't factor, like I'm looking at something like number 6, right? You can't factor that. So what do? This is where that list of possible rational roots comes in. That's when I'm going to take all the factors of 25 and divide them by the factors of 2. And I'm going to plug them in until hopefully someone works. Once I find one, then I'll be down to something that's x cubed. So maybe with that, I'll have like a 4-term thing that I could split in half and factor both sides. If I still can't factor it, I'm still plugging in numbers in my list until I find somebody else that works. Then I'll be down to something that's x squared. Once I get down to x squared, I know I can solve it because I can just either, if I can't factor it, I can do quad formula or complete the square. So that's how you would attempt something like number 6, because I can't factor it. So I'm going to start with those possible rational roots, plug them in until somebody works. Then I'll try and factor what's left and see if I can go from there. Okay. Are we all right with 4? Round 4? Do you want me to do 6? All right, I'll do 6. So possible rational roots. Remember how we find them. I take all the factors of 25. So that's 1, 5, and 25. And I'm going to divide them by the factors of my lead coefficient, which in this case is 1 and 2. I want positive and negative, all of them. So I'm going to take all of these numbers, 1, 5, and 25, and I'll divide them all by 1. So I get 1, 5, 25. And then I also take all of these numbers and I divide them by 2. So that would get me 1/2, 5/2, and 25/2. So if I have a rational root, it's in this list. So now I just have to do synthetic until somebody works. I don't suppose anybody has found one that works already, have you? Let's see, I'm going to drop down my numbers. 2, negative 15, 23, 15, and negative 25. As soon as I feel like one of my numbers isn't going to work, I'm going to stop. So I'm just going to literally start with 1, then I'll try -1. Then I try 5, then I try -5. Then I try 25, then I try -25. If I have to try the fractions, I'll try the fractions. Someone in this list should hopefully work. All right, so first person to find it, let me know. So 5 works? Oh, thank you. All right, so we got 10, -5, -25, -2, -10, 5, 25. There we go. Oh, yes. And what's left is factorable. Hooray. How do I know? Because look, I have 2 and a 5 and a 2 and a 5. They're just signed to swap. But anyway, so that's my remainder. Constant, x to the first, x squared, x to the third. So now if I just kind of write that nice and neatly, I'm at 2x to the third minus 5x squared minus 2x plus 5. Remember, I'm trying to solve this. So now, once I'm down to 4 terms, I can try and factor by grouping. And this one does factor by grouping. So take out an x squared. I'm left with 2x minus 5. Over here, I can take out a -1. I'm left with 2x minus 5. So I get 2x minus 5 and x squared minus 1. Now, x squared minus 1 factors again. So I have 2x minus 5. And that's going to split into x plus 1, x minus 1. So I have, how many answers was I supposed to get? 4. I got all 4. I have the 5 that we found in the beginning. Oops. Right, or really Ethan found it, so thank you for that. So we got 5, and now my remaining 3 are right here. This answer is just going to be 5/2, so right up top, 5/2. This answer is going to be a -1, and that one's going to be a +1. So my final answer there it is for number 6. I got 5, 5 halves, -1, and +1. Oh, so +1 should have worked, but whatever. Cool, we got all 4, hooray. All right, round 5, here we go. Now we're going the other way. This is backwards. They're giving me the zeros and I have to come up with what the polynomial looks like. Let's do one like number 3. First of all, before we even start, you can tell me what the degree should be. It should be to the 3rd because there's 3 zeros here. 1, 2, 3. So my final answer should be something to the 3rd. All right, so our easiest way is to start with this and come up with that sum and product. The sum would be 2. The product would be, I don't know yet. Boil that together, we get a 1. Insides, outsides cancel, last is a -6. So I get -5, did you? So in other words, this is coming from x squared minus 2x minus 5. That polynomial produced those 2 zeros. So now all I have left to do is to multiply it by the factor that produced this 0. So if -3 halves is the 0, what's the factor that it came from? Keller? 2x plus 3. Yes, I'm going to write it out in front here because that's how I like to do it. 2x plus 3, right? Wouldn't you -3 divided by 2? And that would give me -3 halves. All I have to do now is multiply these 2 together and I'm done. So 2x times all that, 2x to the 3rd minus 4x squared times by 3. I should have 6 thingamajiggies before I combine my terms. Yep. And then I just write it in standard form. I'll be done. Ta-da! Oh my gosh. You just came up with a polynomial that has those 3 zeros that they gave me in the beginning. Huh. You could check this too if you really wanted. You could plug in -3 halves and make sure you get out a 0. You could do it synthetically, right? So fancy. Oh my gosh. It is to the 3rd, which we were expecting. So that's a good sign. All right, cool. We are almost done because we don't have to do round 7. Round 7's not. I'm not going to make you, I don't think there's even a graphing calculator part, so don't worry about round 7. And, oh, round 6, so easy. All we're doing is evaluating using synthetic substitution. Guys, evaluate means that the answer is just a number. Stop putting all variables and exponents on it. It's just the remainder. You just plug in the number and whatever the remainder is, that's the answer. So, I don't know. What looks bad? 5, because you got a decimal? All right, let's do 5. It's no big deal. I'm just gonna pull down all my numbers. 2, 3, 5, -1, 3, 2, 1, none. Don't change anything. I'm just taking them as they are, and I'm gonna plug in the number as is, 0.3. We'll drop down the 2. 0.3 times 2 is 0.6. 3.6. 3.6 times 0.3, I don't know what that is, but my calculator sure does. 1.08. Add that to a 5, that would be 6.08. Multiplied by 0.3. 1.824. And combine those two, 0.824. That's my answer. That's it. You are finished. Don't do anything else. If it says evaluate, stop doing extra stuff. You want to double check this answer? I mean, you got a calculator. Just plug in 0.3 directly. Do 2 times 0.3 cubed plus 3 times 0.3 squared plus 5 times 0.3 minus 1. It's going to get you that same answer. But if you really want to check it, go ahead. That's it. So, anybody have any questions? especially if we're skipping round 7. Do you know how to do round 7? You do. You just probably don't think you do. Well, you could make that graph show up on the screen, right? And then it says it's a use it to find or identify a rational zero and then factor the polynomial. All right. So if it has an x-intercept, don't you know how to find the x-intercept? Yeah, it's the same way we did it with parabolas. You would just do second that calc menu, and then you choose 0. That's it. Any hoosers. I've talked enough. Any questions real quick before I just let you work on it on your own? Everybody's okay? Yep. One on round 1? Oh, round 3. Round 3, number 1. Okay, so they gave you a root, you have to find the remaining. So we're going to synthetically pop in a 5. So let's pull down our coefficients. I'm going to go over here so I have a little bit more room. 1, I don't have an x cubed though, so I have to put in a 0 placeholder. X squared is -17, x to the first, -34, and then -30. I'm going to plug in 5. I should get a 0 right now. Sorry, I didn't realize I was off. I should get a 0 because they're telling me, hey, this is a root. So when I do this, if I don't get a 0, oops. If I don't get a 0 as a remainder, I know that I did something wrong. So let's see what we get out. That's 8. So that's 40, 6, 30. Hooray! We got 0 as a remainder, just like we should have. So now I'm down to something that's x to the 3rd. Constant x to the first, x squared, x to the 3rd. All right. So now I'm here. And now, unfortunately, ooh, this is a good one because this doesn't factor. Like I can't factor by grouping here. Oh, bummer. So what do? I'm gonna have to do my possible rational roots, right? I can do it with the simplified version though. I don't have to use it for the original because I'm just trying to solve here. I'm trying to find roots. That's the difference of when I can do like a simplified version and when I can't. So if I'm just solving, I can, you know, hack away at things until I get easier and easier and easier. So I'm here. Let's look for our possible rational roots. Any factors of 6 that divide over factors of luckily just 1. So my possible rational roots are just positive and negative, 1, 2, 3, and 6. So I'm just going to have to go down the line and plug them in until someone gives me a remainder of 0. Oh, and this is, you know, this hasn't happened yet. Guys, look at all my numbers. They're all positive. I'm never going to plug in a positive because how would it cancel out to be a 0 over here? You get what I'm saying? Don't bother plugging any of the positives in this example. So I'm going to start with a -1. Just cut my workload down in half. It's so nice when that happens. -4, 4. Okay, this -1 did not work. So let's try -2. Oh, close, but nope. I didn't get, unless, did I mess up? I don't think so. Nope, I didn't mess up and it didn't work. All right, -2 is out. Let's try -3. There we go. I've got it. So now here's my, here are my coefficients of my answer. Remainder, I don't care about. Constant, x to the first, x squared. So now I'm really dealing with x squared plus 2x plus 2. That's a quadratic. I can solve it. But I can also factor this one, right? Factors of 2 that add up to be 2. Oh, no, it doesn't. Oh, bummer. I can't factor this, but I can solve by completing the square. Right? Aren't the conditions right? A is 1 and B is even. So that's going to be my best bet. We'll see the other side. I want to take half of b and square it. So my magic number is just a 1. So I've got x plus 1 squared equals -1 square root, square root. So I got x plus 1 equals positive and negative I. Don't forget positive, negative. And I just got to minus the 1 over. So my other two answers besides 5 and -3, it's going to be -1 plus and minus I. Ooh, what a doozy. So my final answers, let's write them all nice and neat over here. We found 5 worked, we found -3 worked, and now I have -1 plus minus I. And there they are. How are we feeling? All right-ish. I have an answer key. I'll post it on Jupyter so you can check against the key. Feel free to ask me questions. I am after school today too, so what luck! My gosh. All right, so everybody's good right now? All right, so let me go put up that key. I'll stop this video and we'll go from there.